I want you to close your eyes for a second. I mean, don't close them if you're driving, but I want you to picture a pizza place.
Okay, I'm picturing it. Are we talking like a fancy wood-fired place or just a corner slice shop?
Definitely Friday night chaos. Phones are ringing, chefs are shouting, flour is flying literally everywhere.
Right.
Now, usually when we talk about advanced machine learning, we picture, I don't know, sleek server rooms.
Cool blue lighting?
Exactly. Lines of code falling down the screen like the Matrix. We definitely aren't picturing a pepperoni pizza.
But today we are.
Today we are. Because if you want to understand how to actually deploy artificial intelligence, not just design it in a lab, but make it work in the real messy world, you need to understand that pizza kitchen.
I love that. It's the perfect entry point because it grounds something that usually feels so abstract.
Welcome to the deep dive.
Oof.
Today we are unpacking the career and the insights of Muhammad Abiodun Sulaiman.
He's a machine learning engineer at Data Science Nigeria.
And his journey is honestly a roadmap for anyone trying to figure out how to bridge the gap between coding and data science.
Truly. And looking through the source material, what jumps out right away is that Muhammad is not your typical academic data scientist.
Right.
He didn't start in a math lab proving theoretical models. He started in software development and process automation.
He is a builder at his core.
He is, and that distinction matters so much. There is a massive gap right now in the industry between saying, you know, I can write a model in a Jupyter notebook to predict housing prices, and saying I can build a system that serves 1 million users without crashing. Muhammad lives right in that gap.
So if you're listening to this and you're wondering how to actually move from just writing code to generating actionable insights.
Or if you want to know why users spending less time on your app might actually be a sign of massive success.
Oh, that is a great teaser. We are going to get to that engagement paradox soon, so stay with us.
We have a ton to cover. We are breaking down his transition from dev to data, the specific soft skills he uses, and yes, that pizza analogy for modern APIs.
Let's start with that origin story. You mentioned he started in software development. Why is that specific background such a leverage point for him now?
Because usually we think of data science as pure math.
And software dev as pure engineering.
Right. It comes down to how you view the purpose of the data itself. Muhammad talks about 2 distinct phases in his motivation. Phase 1 was very standard.
Descriptive analytics.
Exactly. Just using data to get answers, asking what happened yesterday.
Looking at a static spreadsheet of sales from last month?
Yeah, it's basically a rear-view mirror. But because he was a developer first, he was already thinking about automation. He wasn't just looking at the data. He was trying to streamline the entire process of retrieving it.
And that mindset kind of forced him into phase 2.
Which he calls the evolution, moving from what happened to what will happen, predictive analytics.
But the kicker is he doesn't just want a prediction.
No, he wants a scalable system that acts on that prediction automatically.
That's a subtle difference, but it feels incredibly important. Can you break that down for us?
It is huge. Look, a pure data scientist might be totally happy with a model that is 99% accurate on their laptop.
They high-five themselves and say they solved it.
Right. But a software engineer looks at that same model and asks, okay, but how does this scale? What happens if 10,000 people hit this endpoint at exactly the same time?
What if the data feed breaks?
Exactly. How do we version control this thing? Muhammad's superpower is that he anticipates the breakage before he even builds the model.
So he treats AI not as this magic trick, but as a standard software component.
Precisely. He is drawn to the transformative power of turning raw information into action, but he views it strictly through the lens of reliability.
Which brings us squarely to the tools he uses to guarantee that reliability. I think it is time to fully unleash the pizza analogy.
I have been waiting for this. Let's serve it up.
Okay, so one of the specific technical tools Muhammad highlights heavily is FastAPI.
A modern web framework for building APIs with Python.
Right. But technical definitions like that can be a bit dry.
Very dry. Give me the cheese.
So Muhammad explains it like this. Imagine you are the customer. You are sitting on your couch, you're hungry, you pull out your phone to order a pizza.
You are the client.
Yes. And the kitchen, where the pizza's actually made, where the dough is spun and the oven is firing.
That's the serve.
Standard client-server architecture.
Yeah.
But how do they actually talk to each other?
Right, because you don't just walk into the back of the restaurant and start shouting at the chefs. That would be total chaos.
You need an intermediary. You need a waiter or, a digital system that takes your order. That is the API.
And specifically, that is where FastAPI acts as this super efficient assistant.
Let's dig into why it's super efficient, though, because there are a lot of API frameworks out there. Why FastAPI for a machine learning engineer?
This is where the fast part really matters. In older synchronous systems, it's like having a really slow waiter.
Okay.
He takes your order, walks all the way back to the kitchen, waits there for your pizza to be baked, brings it back to you, and only then takes the next person's order.
Which is terrible for business. You would have a line out the door instantly.
It's synchronous blocking. It's incredibly slow. Muhammad highlights FastAPI because it handles things asynchronously.
The waiter takes your order, pins the ticket to the board, immediately turns around, and takes the next order.
Creating a high-throughput system, it handles the communication between computers quickly, so the service runs without bottlenecks.
And there's another layer to this analogy that he touches on, which is validation.
Oh, right. This is make or break for a data engineer.
Because if I try to order a Toyota Camry on a pizza menu, a bad waiter might just write it down, take it to the kitchen, and the chef has to stop everything to figure out what is going on.
They can't cook a car, wasted time, wasted resources. And in the data world, bad input might just crash your entire server.
Exactly. But FastAPI checks the menu instantly. It says error, invalid item. It stops the bad data right at the door.
And for someone like Muhammad, that is everything. If you send bad data into a machine learning model, you get garbage out. Or worse, the model just fails silently.
So he uses this tool to ensure that data entering his system is clean and structured before it ever touches his complex algorithms.
It acts as a gatekeeper and a traffic controller. It is the glue that turns a theoretical math model into a reliable service for a mobile app.
It really reinforces that builder identity. He isn't just cooking the pizza, he is designing the restaurant layout so the food actually gets to the table hot.
That is a great way to put it.
I want to pivot to one of the specific projects he discussed, because this is where the theory really hits the road.
The recommendation engine.
Yes. He led the development of a recommendation engine. Now, if you're listening, you interact with these every single day.
Netflix, Spotify, Amazon, if you liked this, you will love that.
But Muhammad points out a massive tension here between the technical and the creative.
The technical challenge is just the math of predicting what a user will click on.
But the creative challenge is personalizing it for diverse users and handling all those weird edge cases.
The human element. What happens when a user doesn't fit the standard pattern?
Right. And this leads to what I think is honestly the most counterintuitive insight in this entire deep dive.
You are talking about the engagement paradox.
Let's set the scene. You are an analyst. You're looking at a dashboard for a digital product. You see a group of users who log in, click one thing, and log out very quickly. Low time on site.
The alarm bells usually start ringing immediately.
Yeah.
In the attention economy, we are deeply trained to think that time spent equals value. If they aren't scrolling forever, they must be bored.
We assume high engagement equals strong retention.
But Muhammad looked closer at the data for this specific product.
And what did he find?
He found that the users with the lowest engagement metrics, the ones spending the least amount of time on the app, were actually the most loyal. They had the highest retention rates.
Which blows your mind at first. Why were they leaving so fast?
Because the product was working perfectly, they logged in, found exactly what they needed immediately, and got on with their day.
They were efficient.
Think about a weather app. Do you want to spend 20 minutes on a weather app?
Definitely not. I just want to know if I need an umbrella.
Exactly. If you have to spend 20 minutes clicking around to find out if it is raining, that is a terrible user experience.
It's the difference between TikTok and Google Maps.
That is the perfect analogy. You want to be on TikTok for an hour. That is entertainment. If you are on Google Maps for an hour, you are lost and frustrated.
Yeah, nobody is scrolling Google Maps for fun.
And Muhammad's team realized this. If they had tried to fix those low engagement numbers by forcing users to stay longer,
Like adding annoying pop-ups or gamification.
they would have alienated their best customers. They would have optimized for a vanity metric, but completely failed the human using the product.
And that is such a dangerous trap. We get so obsessed with the dashboard that we forget the reality it actually represents.
So his team shifted their entire strategy. They stopped trying to maximize time on app and started focusing on efficient, valuable user experiences, time to value.
Which is so much harder to measure.
It is. It requires actual empathy. You have to understand why the user is there in the first place.
And I think that leads perfectly into how he developed that level of intuition. You don't just wake up one day with that kind of strategic insight.
No, he credits a lot of his career leaps to mentorship. But he didn't just have one single mentor who taught him everything.
Right, he diversified. Let's break down the two main types he mentioned. First was the strategic mentor.
This is the person who pulls you out of the code editor. They taught Mohammed to align his solutions with actual business goals, not just technical specs.
They asked the annoying but necessary questions.
Right, like, does this model actually save us money? Does this feature drive revenue?
The business why.
Exactly, because you can build the most advanced neural network on the planet, but if it doesn't solve a business problem, it is just an expensive science fair project.
And then on the flip side, he had the technical mentor.
The plumber. This mentor introduced him to DevOps and CI/CD.
Continuous integration and continuous deployment. Now, for the listener who hears CI/CD and their eyes glaze over, why is this so critical for a data scientist?
Imagine you have a model that predicts stock prices. You write the code on your laptop, it works perfectly, but now you need to update it every single day with new data. Do you manually copy and paste files to a server at 3 in the morning?
I certainly hope you don't.
CI/CD automates all of that. It runs automated tests every time you save your code to make sure you didn't break anything, and it automatically pushes the update to the server safely.
It's the infrastructure of reliability. So one mentor taught him what to build strategically, and the other taught him how to deliver it at scale.
That combination is basically lethal. It covers both sides of the coin.
But even with great mentors, things still go wrong. And I really appreciated that Mohammed shared a pretty major failure story in the notes.
Ah, yes, the case of the perfect model. The lab versus the wild problem.
Every data professional has a scar from this.
Oh, yeah.
So the situation was he built a predictive model. In the testing phase, it was hitting bullseyes. High accuracy, working perfectly.
Green lights across the board. The team is probably celebrating.
Then they actually deploy it to the real world and it just flops. It fails to deliver consistent results. What usually causes that?
He doesn't give the exact root cause for this specific instance, but in the industry, this is almost always data drift or concept drift.
Break that down for us.
The data you use to train your model comes from the past. It's historical, but the real world is constantly changing.
Right.
Maybe consumer behavior shifted overnight. Maybe the economy changed. The model is still looking for patterns from last year, but the world has completely moved on.
So the map no longer matches the territory.
Exactly. And the huge lesson Muhammad took from this wasn't that he needed a better algorithm. It was that he needed better validation.
He talks about prioritizing flexibility and continuous validation to match practical realities.
Practical realities is the key phrase there. You have to work closely with stakeholders to understand the actual environment the model lives in.
Because a model that is 80% accurate but robust when things get weird is so much better than a fragile 99% accurate model.
Absolutely. And that resilience is actually the first item on this great list he provided of overlooked skills in the data field.
I love this list because none of them are programming languages. You can learn Python on YouTube. These skills are much harder to find.
Let's run through them. So we have resilience, which we just covered, bouncing back and adapting when the model fails. Then we have problem framing.
Which goes right back to the engagement paradox.
Yeah.
Are we solving for time on site or user satisfaction?
If you frame the problem wrong, your solution is useless. You could build the best bridge in the world, but if the city actually needed a tunnel, you failed.
Next on his list is data storytelling.
This is the bridge between the complex numbers and human decision-making. You have to be able to explain the so what to a CEO who hasn't taken a math class in 20 years.
If you can't persuade people to act on your insights, your analysis just sits in a drawer gathering dust.
Exactly. Then there's ethics,
Which is quickly becoming the defining issue of our time with AI.
We're talking about algorithmic bias, developing fair and transparent AI. Muhammad emphasizes that you really have to understand the impact of what you're building on real people.
It's not just abstract data points. It's people's credit scores, their job applications, their medical records.
You have to constantly ask, is this fair?
And finally, a technical one that often gets completely skipped in data boot camps: version control.
Ensuring your code is reproducible.
Why is this overlooked?
Because data science can be really messy. You're experimenting, changing variables, trying different parameters. It's so easy to lose track of what you did.
Version control is the discipline of tracking every single change.
If you get a great result today, can you get that exact same result 6 months from now? If you aren't using version control, the answer is usually no.
It's a really comprehensive toolkit. It paints a picture of a whole engineer, not just a coder.
Now, before we close out, we have to look at the culture piece. Because Muhammad isn't working in a silo. He is actively building a data-driven culture at Data Science Nigeria.
And we all know that just emailing a massive spreadsheet to the marketing team doesn't actually make them data-driven.
No, that just makes them angry. They don't want raw numbers, they want answers.
So what is his approach to building that culture?
Accessibility. He creates very user-friendly dashboards and visualizations. He doesn't expect the marketing team to learn SQL.
He also holds regular data workshops to help non-tech team members understand the core metrics.
Which is such a high leverage activity. If you can teach a product manager how to read a retention cohort properly, you turn data from a black box into a shared language.
Suddenly, the whole company is moving in the exact same direction. For the listener who is inspired by all this and wants to build this kind of profile, Muhammad gave us a rapid-fire list of resource recommendations.
It's a very solid list. I would definitely take notes here.
For books, he recommends Data Science for Business by Foster Provost.
That is basically the Bible for problem framing. It's all about how data actually applies to business strategy.
He also suggests Hands-on Machine Learning by Aurélien Geron.
That's your practical guide. When you are ready to actually write the code, that is the manual.
And Storytelling with Data by Cole Nussbaumer-Knaflic,
which covers the visualization aspect, how to make charts that actually communicate rather than just confusing people.
On the course side, he recommends Andrew Ng's Machine Learning on Coursera and Fast.ai.
Andrew Ng's course is where almost everyone starts for fundamentals, and Fast.ai is fantastic for a more code-first, builder-centric approach.
And finally, communities, Kaggle and GitHub.
You have to go where the builders are. Looking at other people's code is arguably the best way to learn.
So let's try to synthesize this incredible journey. We started with a pizza delivery service and ended up with a philosophy of ethical AI.
It's quite a trajectory. But I think the core thread tying it all together is balance.
A software developer who became an ML engineer. A builder who realizes that technical perfection is useless without business alignment.
A data professional who understands that low engagement can actually be a sign of high user value.
It really challenges the stereotype of the lonely coder in a basement. Muhammad's career proves that the best engineers are actually hyper-connected to the business, to the user, and to their team.
Absolutely.
I want to leave you, the listener, with one final thought on empathy. We live in a world of automated recommendation engines. Algorithms decide what news we see, what products we buy.
Sometimes even who we date.
Right. And it is so easy to get lost in the optimization, to treat people as mere data points to be maximized.
We optimize for clicks, for time on site, treating human attention as just a commodity.
But Muhammad's story asks us to look much closer. The most successful engineers aren't just the ones who know the complex math. They're the ones who understand the human on the other end of the algorithm.
The ones who realize that a user leaving the app quickly might just be a happy human who found exactly what they needed.
So for your next technical project, ask yourself, are you optimizing for the metric or are you optimizing for the human? How can you apply that user empathy to your code today?
That is the question that turns a good project into a truly great one.
Thanks for diving deep with us today.
Always a pleasure.
See you next time.